return a single value after calculating from a group of values.
Which new students?
Assuming that Wamusi, can you mute yourself? Assuming that we have the table called orders. Under orders, we have a table called total price. Assuming that we want to get the grand, what do I call it now? Grand total price, something like that, the total of the price. Then we can decide to do that. We can decide to use the sum functions. So the SQL sum and average, AVG stands for average. In SQL, the sum function and AVG functions are used to calculate total and average values in numeric value. The SQL sum function is used to calculate cumulative sum of numeric values in a column. The syntax is select, sum, then you indicate the column name where you want to calculate the sum from, then the table name. You'll be able to do that. Then you can also use these sum functions or average functions, the minimum and maximum, with group by or order by. We shall see them later on. The simplest example we have here is select sum amount as total from orders. Then, for example, we have here, we can see that select sum amount as total sales from orders, which means that it will only retrieve for you a column, it will compute for you the total amount and store it inside a column called total sales because you have decided to use the alias as. Then we have, where we also have AVG function. The AVG function or the average function is used to calculate the average of numeric values in a column. For example, select average, the column name from the table. The simplest example here is if you want to get the average age, you can see select AVG age as average age from the table called customers. Then you should be able to get the average of these of the ages of the 5 customers. It will give you in this form. Then we have the maximum and minimum. We have the maximum and the minimum function. The maximum function is used to display for you the maximum, the highest. Is it clear? Returns the maximum volume from a column. The syntax is select maximum, the column name from the table name. Then, for example, select maximum age, maximum from age from customers. Then it will get for you, there are 5 customers. The customer with the highest age will be retrieved. Then we have minimum function. That is, it brings for you the minimum age. That is the lowest age. The syntax is select min, column from the table name. You'll find that select min age from customers. Then it will display the minimum age from the 5 customers. If you see that the minimum age here is 22, the maximum is 31. Then you can also use the sum, the average, the minimum, the maximum with aliases. That's why you find that we have decided to use as. Then you give it the name. So you can see here we said select max. We're using the maximum what? Function of age as max. By using as max, you'll find that the name of this column is being replaced with max age. That is where you can use the max, the as, the alias. Then we have the count. The count function is used to count how many records are there in the table. You can decide to say select count all from the table. It will count for you how many records there and display the total number. The simplest example here is select count from customers. It will count for you how many records and then it will display it there. That's why we have 5 records, it's able to display 5. You can also use aliases with counts, such as select count as the total customers from customers. Then it will display for you how many customers we have. We have 5 customers. Then we can also use count with where. That's why you said select count. We are trying to count the countries as customers in UK from customer where the country is UK. If you want to know the total number of customers who belong to UK, then you can write a simple syntax like that, and then it should be able to display for you the syntax. What? There. It should be able to display for you the customers from UK. Then we have what? We have group by. You can also decide to group. That's why you see select country, then count as customers from, like select the count to display for us a country. I'm in a column called country, and then another column that will store the count, and you rename it customers from the table customers, and you group it by the country, which means that it will go to the table and look for the customers who belong to maybe UK. How many of them? It will add them and put them inside the table called customers. The same for USA, and then the same for UK. Then we have having. The other say that you use having with group by. That's why you'll find that this is here is saying that select count the customer ID, the country from customers, then you group it by country, having the customer. If the customers are more than 1, then it will count them and display for you. That's why it's simple. What SQL statement will do for you that. Then before we move to scalar functions, let us see the example of the 4. How they are. What? How many are there? There are 5. Then let me demonstrate it from MySQL. Then after that, we shall move to the scalar functions. Then I'm stopping sharing this, and then I'm going to upload the MySQL workbench. So for example, we are going to use the table called orders. Let us first of all select all from orders. The reason why we are using orders is because orders has something with figures that we can be able to compute. Then, assuming that we want to know the total price there, the grand total price, then we can decide to write a simple what SQL statement to do that. Just matter of typing select, then you put the keyword sum. What do you want to get from the sum? We want to get it from, we want to compute the total, the grand total for the total price. From where? From the table called orders. Then once you run this, you'll see that it will compute for you the total. It will add for you the total prices for all those orders, and it will display it like it is. But here you'll see that the heading is sum. It is trying to display for you in form of a formula. Then you can use the alias s to replace it. Then we can go back and say that we want to use as, we can write it as grand total price, something like that, from the table called orders. So once we run it, you'll find that we shall have a table called, a column called grand total price, which will display it in this form. Is it clear? That is using the sum. Then if you want to know the average, let me just copy this. I can just copy this and paste. Instead of having sum, I replace it with AVG. Then I can name it as grand average price, or I can say it average price. Let me just use the keyword average price. So when I run it, it will get the average of what we have inside there. Then we can still go back to that table called orders. Then if you look at this table, which one is our maximum value? Our maximum value is 1 million. Our minimum value is what? 12,000.
Excuse me.
Then let us go and see whether by using these functions we can be able to get it. Then we can say select maximum. And then as we can say it as maximum total price from orders. So it should be able to display for us, our maximum price here is 1 million. It should be able to display for us the 1 million. When you run it, you'll see that we have what? 1 million. Then we can also do this one for minimum. Can say to say minimum. Our minimum was around 30 something, I think. Let me see. Our minimum price here is how much? 12,000. So when we run this, minimum. When we run this, we should be able to display for us what? The 12,000. That is the minimum amount from there. Then we can still go out again. We can decide to say that let us first of all go here and run the query. You'll find that from here, we have customers, customer 1 and customer 2. They made order 1 and order 2. Customer, that is customer C004 made 2 orders. Customer C001 made order D003 and D004. Then customer C002 made the order D005. Then we can decide to compute the total price, the total sum for each order made by each customer. Then how do you do that? That is where we're now going to group by. We can decide to group by what? The customer ID. Then you can just decide to say that select what? We want to select the sum from, we call it the total price. We want to get the total price. You can name it as brand total price, from where? Not supposed to be that, supposed to be underscore. From the table called orders, then we orders, and then we want to group by the what? The customer ID. Then when you group by customer ID, what happens here is it will go inside there and you'll find that customer, since customer with customer ID C004 made 2 orders of 500,000 and 1 million, it will add 500 to 1 million and display for you for that customer. Then the same thing also happens for what? Customer C001 made orders, that is 12,360. It will add these 2 and also group it. So we want to select what? 1. We want to group it. Let us see it by customer ID. Customer ID. We want the statement to what? To retrieve for us the customer IDs and the totals, the total orders made by that particular customer, and then we group it by the customer ID. So when we run this syntax, you'll see that customer with C004, when you add here, let us go to select and we see. You'll find that the customer what? C001 made orders 12,360. When you add 12,000 to 360, you get 300 what? 72. I think 372. For customer with C002, you find 80,000. But the customer with C004, you'll find 1.5. Then let us run this and see what it will display. That's why you'll find that C005 is 15, 1.5. C002 is 80,000, but C001 is 372,000. That is it. It gets for you the orders made by each customer, since you have decided to group by the customers. Now I'm going to introduce another function. If you don't want to see these decimal places, we can decide to use another function called round. We are going to tell now MySQL engine that let it round for us these figures to 0 decimal places. So you begin by putting it here. We can say to put it before sum. We use the what? The function round. We can use round here, and then we end it somewhere here. We end it here. But you have to indicate how many decimal places you want. By putting comma, for us, we want only 0 decimal places. So once you put 0 decimal places, which means that it is going to remove what? These 5 decimal places, and it will only display for you 372,000 without any decimal place. So let us run it and see what it will display. Have you seen what it has done? It has decided to remove what? Those decimal places. That is how you can use also this inbuilt round function. The work of the round function is to, if you want to round to the nearest decimal places, you can use the round function. You can also do the same for if you want to find the average. You can also copy this instead of here we missed the keyword sum is supposed to be there. Why is it? Yes, supposed to be something like this, so that when you run it, it will be able to display this. Then for us here, if you want to get the average, you put the average, then you can decide to replace this, the grand average price. So that when you run this, it will find for you the average of each. You'll find that the average, since there are 2. Okay, let us first of all to C004. What was the grand total? The grand total was 372,000. When you divide 372 by 2, what do you get? Because there are 2 orders. 372 divided by 2, you find what? 372 divided by 2. You find 186. So let us see whether we shall get 186. That's why you'll find that you have 186. Since customer 2002 made 1 order, you remain with 80,000. Then customer 2 C004 made 2 orders. The total was 1.5. So when you get the average, you divide 1.5 by 2, you're supposed to get 550. Is it clear? Members, is it clear? Yes?
750.
Yes. Is it clear before we move ahead?
Yes,
Any
doctor.
question? Any question? Someone said that, thank you, doctor. How do you do what? The values with the commas. Which commas did you use? Dramiga?
I guess it's meaning the 1,000 separator. Where I want to display it.
Why did you use the commas?
No, I think it's meaning the distance you actually saw to show the separator. If you wanted this,
to show it, indicate it.
Yes, that is what I'm thinking. He's around, he can explain it better.
Yeah, I was trying to know that if the values can be displayed in a comma, maybe say displaying the 186,000, maybe
186 comma and so on.
Just like that.
To be sincere, I've not tried to find a way of doing that. Okay. I've never thought about it.
All right.
Hey.
Thank
now,
you.
assuming that we want to do what? Assuming that, let me even remove this. You can do the rest. Let me remove this statement out. Now, assuming that we want to write a simple SQL statement that should display for us the total orders made by each customer when the total order or the grand total price is greater than, maybe we can say 700. Is it clear? That is where you're now going to use the having. Since we are using groupings, it becomes very easy. We can say select customer ID from this grand total, select customer ID, then find the total sum of the total prices, the orders made by that customer, and you round it to 0 decimal places and you store it inside the column called grand total. Then order by, order by what? From orders, and then you group by the customer ID. Now, assuming that I want only it to display for me the list of customers who made a total order, maybe more than 700,000. Then I can say to come here and use my having. I say having, then you put having what? Having this grand total. Excuse me, having the grand total greater than 700,000, 1, 2, 3. What we're trying to do here is we want only the MySQL engine to display for us the list of those customers whose grand total price is greater than 700,000. So that simple what SQL statement can be able to do it. Now what we're going to do is, since we're going to run multiple things, let me first delete that and then we run this and see what it will display. We run this and then we run. What does it say? Operands should contain 2 columns. Which operand? Select customer ID, sum grand total, as grand total from orders grouped by customer ID, having the sum of total price. When you put this will be greater than that. I think this word keyword round is missing. Is greater than this. We run it. What is missing is displaying for us E. You have an error in the syntax. What is that error? Select customer ID, round sum of total price, 0, from orders grouped by customer ID, having, let me even remove this round and see what it will display. Having total sum is equal to greater than 700,000. Yes, it's only saying that it's one person who has the grand total of 700,000. Can you give me 2 minutes? I'm coming.
Okay, doctor.
Yes, I'm back. Let us go and see the grand total for each. What was the grand total for the first one?
$186.
The first one, the grand total. I haven't deleted it. It's just having this. You'll find that the grand total for the first one is 370. The second one is 80,000. But the fourth one, that is C005, has the grand total of 1.5. That's why it's only able to display for you a customer with C004, because he or she is the only one who has the grand total of more than this. What about we decide to reduce this to 300,000 and then we run it? what will it display? If we run this query, you'll see that it will display for us the 2. Because C005's brand total price is 375, which is greater than 300. That's why it's able to display for us that. Is it clear, members?
Yes, doctor.
Now, if we want to know, maybe now we want to write a simple SQL syntax to know how many orders were made by the customers. We can decide to use the count function. So we can decide to just say that, we can decide to say, write a simple one, we say, select the customer ID, I need it, customer ID, comma, then we want to count. We want to count how many orders were made. We can decide to say count as, let's see, count as, we want to count what? We want to count the customer ID. We want it to display this, but we want it to count the customer IDs. How many orders the customer has made. Count customer IDs, we can say to say number of orders from table called orders. Then we group by the customer ID. Just copy that. Group by the customer ID. That is all. So that when we run this, you'll find that it will show you that the customer with C001 made 2 orders. Customer with C002 made 1 order. Customer with C004 made 2 orders. Even if you go and you select all from the table called order, from orders, you should be able to see that, you see the orders made by each customer. That's why you'll find that customer with C004 made 2 orders. That is D001 and D002. Customer with C001 made 2 orders. That is D003 and D004. Then customer C002 made 1 order. That is D005. That's why this simple query is able to display for you the count. Is it clear up to that level? Are we clear with the
Yes,
aggregate
doctor.
factor?
Yeah, it's
Yes,
okay.
doctor.
Then let me stop.
Yes,
this.
yes, we are following.
Then let me stop this and we start with what? Let me stop this. Then we go back to our slides. Then hello? Okay, members, let us now look at scalar functions. Scalar functions return a single value from an input value. For example, there are many types of scalar functions. We know that one of them is uppercase. We know that when we were entering the data, we call what? We decided to capitalize each name of the customers. But if you want to convert the names of the customers into uppercase, then you can decide to use the inbuilt function called ucase. So ucase function is used to convert values of string columns to uppercase characters. The syntax is select ucase, and then you mention the columns from the table. Then, for example, in this example here, you'll find that the names here in small letters. If you want to convert them into capital letters, you just say select ucase and then the name from employees. So when you run that particular one, SQL sentence, it will convert these ones. It will convert these names into uppercase. It doesn't mean that it converts it permanently. No, it only converts it when you run that SQL statement. Once you remove that SQL statement, nothing happens. It goes back to its original name. That is the use of ucase in build function. Then we have lcase. Lcase, you use it if you want to convert the string into lowercase. Instead of having u, you just replace u with l. It will convert for you. These ones here, you'll find that these ones here are all in what? Lowercase. So if they are in lowercase, and there's no need even for you to convert it into lowercase, because they will still remain in lowercase. Then we have what we call the mid function. The mid function is used to extract substrings from a column values of a string type. Assuming that you have a long text, maybe you have the names of people, but out of the names, you want only to extract values from particular range and to end somewhere. You are going to use the mid function. The syntax for mid function is you put the mid, then you indicate the column name. You indicate the column name, maybe name. Then where do you want it to begin to extract from? Then you count the characters. The first character letter there is the first is 1, 2, 3, and 4. And then you indicate the starting point where you want it to begin extracting from. Then followed by how long you want to extract that. Maybe you want to extract 2 letters, maybe you want to extract 3 letters. Then you indicate it. Then start, then length from the table name. You indicate the table name. For example, from here, assuming that we want to select what? The mid name. We want to select some characters from the name. We want to start from 2, which means that the first letter here is 1, this is 2, this is 3. 1, 2, 3, 4, 5. But we want to start how many? From 2. That is, we want to start from n. Then it will display for us n. And then how many more characters? What is the length? We want only to extract for us 2 letters. Then it will display for us nu. Then it will display for us HM, OH, CO, and IG. Let us see, that's why NA, HA, OE, CO, and then IG. So that is a simple example of where you can use the mid. You'll find that some of these functions, you'll not use them frequently, but it's better you know it. Then we have the round. I think we talked about round when we are rounding what? The decimal places. The round function is used to round a numeric field to the number of the nearest integer. It is used on decimal point values. The syntax for it is round the column, indicate the column where you want to round the decimal places. Then how many decimal places do you want to round to? 1, 2, 3, or whatever it is. Then you indicate the decimal places, decimals. Then from where you indicate the table name. For example, we have this example, we have a column called salary in this particular table. If you want to maybe to round these ones to 1 decimal places, then it will what? It will since 0.67, 7 is more than 0.5, then more than 0.4, it will add 1 to this, then it becomes 9,000.7. This one will become to what? It depends according to the decimal places. If you put 0, you want to round to 0 decimal places. Since this is 0.67, it will add 1 to this. It becomes 9,001. For this one becomes 8,001. This one remains 6,000, 1,000, and then this one remains 800. That is when, if you want to round to 0 decimal places, you'll find that here they did not indicate it. Even if you don't indicate it or you indicate the 0, it will still do the same. Then that is the round function. Then the other one is also concatenate. Much as I did not indicate it here, you can have another function called concatenate. Let me duplicate this. Duplicate. We can decide to have what? Concatenate. The concatenate character, function. You can use it. You can use the concat function to do what? If you want to combine some string, assuming that we have first name and then we have last name. we have decided to put it in different columns. But if you want to combine them as one particular column, then you are going to use the concat function. So how do you use the concat function? The concat function is very simple. It's just like the other one. Like what you do is, let me put concat function. The syntax is concat, select, then you put the keyword what? Concat. Concat. Then you indicate, well, first of all, what? The column name. The first column name. We use this. The column name. Then, comma. You are going to create space between these ones. Assuming that you want to combine first name and last name to be a name, then you have to create space them. To create space, you are going to use what? You are going to use double commas. Then you put comma and then another column name. And then you make sure that there should be space between the commas. Then from where you indicate the table name. Indicate the table name. For example, in our example, we have columns called first name and last name. If we want, excuse me, if you want to write a simple example that can combine the two columns to make one column, then this is what you're going to write. We can have this syntax here. Let me put it like this. We can decide to have select. We can decide to have, let's take this. We can decide to have what? We can decide to have select, concat. We are going to have first column, first name. Then we are going to have last name. How we named it in the columns, in the table. Then we have to give alias for it, what we want to concatenate. Then you can use the as function. You are going to give the as what? We can call it full name. From the table, customers. So what it will do here is it's going to be very simple. It will get for you the first name and last name, combine them as one full name and display for you. So we are going to also see concat. So for these 5 different examples, functions, let us first of all see them practical and see whether they work. So what we are going to do is I'm going to stop the slides. Let me stop the slides. Then I'm going to start my Sql workbench. Then for us here, we're not going to use what? Orders. Let us now use for this one. Let us use what? Customers. Select all from customers. And then we run. Now, from here, you'll see that when we run that, when we want to display all the records in the customer table, you'll find that we have customer ID, first name, last name, sex, date of birth, phone number, country, email address, and nationality. So let us first of all convert all the first names and all the last names into uppercase. So we are going to use the ucase what? Function. You can say to say select. Select what? You type the keyword ucase. You start with the first one, first name, comma, then you put ucase again for last name, from what? Customers. The table was called customers. So when you run this simple SQL statement, it will convert, it will only display for you the first name and last name, and all the values inside here will be converted to capital uppercase. So let us run this. You'll find that it will display for you the ucase first name and ucase last name and convert them into uppercase. You can decide to use even as here. As what? First. then as last name. If you want these headings to appear properly, you can modify that so that you'll have the first name and the last name. MySQL will automatically convert them into uppercase. That is the U case. What about if you want to, if we go back there, you'll see that the first letter is in the names. The first letters are in uppercase, but we want to convert everything into lowercase. Instead of having U case, you just type L case. L stands for lowercase. So that when you run this SQL statement, you'll find that it will convert everything here into lower case. So that is converted into lowercase. Now, the other thing is, assuming that we are done with uppercase, we are done with lowercase, now we are going to meet. Assuming that we want to extract 3 characters from the first name, and we want to begin from the second character. That is, you'll see that we have ASICO. We want to start from S. Here we want to start from A, one from D, one from Z and M, but we want to extract 3 characters. This is where we're now going to use what? The mid. We can decide to say, instead of having this, we can decide to say mid, select mid what? And then you indicate the column where you want to select, extract from. We want to put from first name. Where do we want to start extracting from? We want to start extracting from the second character. And then how long do you want the characters to be? We want only 3 characters. So when you run this, we can decide to say maybe mid name. Let me give it the title here, mid name. So when you run this, it will start extracting from SIK, ABI, DEB, ZIK, MAZ. Then when we run this simple example, you'll find that it will only extract. It will begin extracting from the second character, and then the length is 3. What about if you indicate the length to be what? 4. Increase it to 4. You'll find that it will go to Siku, Abibi, Debo, Ziku, Mazo. Is it clear now? Is it clear, members?
Doctor, what I wanted to know,
Yes.
that now that will it bring an error? Let me assume if like you've put the length to be 4 and someone's name is 3 letters.
Let us see it. Let us put 5. You'll find that ASICO is 5 characters. Is it clear? But we're starting from S. What will it display? I strongly believe it will display those characters which are there. Those ones which are not there, it will leave them out. That's why you'll find that it will still display for you the same thing. Is it clear?
Yes, Doctor, it is.
Yeah,
Thank you.
Yes.
Yeah, that is when you want to use what? Mid. Then to use round, I think I was able to show you people the example where you can round. Should I also repeat it? Round
Yes.
round to the nearest number. We used it when we were using the what? The aggregate functions, when I rounded those decimal places to whole numbers. Then I assume that we did it, or we can just decide to say select what?
Maybe is it possible?
Okay, let us do it. Orders. Let us go back to order table. Select, yes?
Excuse me.
Yes.
Can round work for characters?
Okay. Someone is asking a question here.
Like you are saying, you are picking from the second character.
Yes.
You find that K is picked from the third character. So you look at the order.
Is it from third characters or from second? ASICO.
Start from where does it start from 0? It starts with 1.
1. It's not using index.
Okay, doesn't use index.
It's just using the whatever our normal 1, 2, 3, 4, 5 characters.
The
first one is L. For ASICO,
the second one
then S.
is O.
Yeah, it starts from S and then it proceeds.
Okay.
It's clear. Now, what I think that, yes, I think that is Torome, right?
Yes.
Yes. What are you saying?
Huh?
What are you saying?
That is my name. I'm
Yes,
asking.
I know. Hey.
And round also work for characters.
No, 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 no. No, it's only for decimal places.
Okay, okay.
You cannot run maybe round E to M. It's not possible. It's only for numbers with decimal places.
Okay, it's okay.
Any other person? Okay. Let me run this and we see what is in what? The table called orders. Now, table orders had the order ID, the customer ID, the product ID, and the order date. But we're interested in what? Total prices, because it is in decimal places. I think that is 5 decimal places. Now, assuming that we want to round this maybe 5 decimal places to 2 decimal places, we can write a simple SQL statement to do that. We can just decide to say select for us. Select. What do we want you to select? We want to select, then you put the round keyword. We want to select what? The total price. The total price from the table called orders. So when you round this, now you have to indicate how many decimal places do you want to round. Is it clear? Our decimal places, there are 5. If you want to round to 2, let us see, we round to 2. You'll see that it will eliminate the 3 because it will round it off. You'll remain with what? What did we do? We have decided to round to what? 2 decimal places. Let's see. By default,
the syntax, is it okay?
The syntax is okay. It is just this keyword called round. It has decided to round it automatically. Because we have here, assuming that we have this one as, let me try to edit. Let me see whether I can edit this. That is orders. Right click, alter table. Let me see whether I can update the values. No, so this is not what I want. I think you do it from here. Assuming that I want to put this one as 756. Then we put this one as maybe 45. Since there are 5 characters, then we want to put this one maybe 1, 2, 5, 6, 7. Then we want to round this one to maybe 5, 9, this. Those are 5 characters, right? Then let us leave the last one. Now, assuming that this is what we have, we select all from, let me see, customers. Customers. Then let us select all from orders. Let me see whether those values are updated. Yeah, did not save them. I wanted to edit this. Let me, it's this one, I think. Let us assume that we have 87651. Then we want to edit that. Edit. Where do we save it? Okay. Let us just use the syntax.
Doctor, you may have to apply on the right.
Yes.
Doesn't apply if it's on the extreme right of the. No, down.
Apply is down.
Hey, this
Down.
one, apply changes. Yeah, we're supposed to apply changes. Okay, let us just do for that one customer. Now, assuming that we want to do what? We want to select, we want to round this same customer. We want to round this order D001. Select all from orders where order ID is what? Is what? D001. Is it clear? So we want to round this one here, maybe to 2 decimal places. And then when we run this SQL, what shall we see? You'll see that here it has decided to round it. Is it clear? We can decide to select what? I wanted it to display all these ones here, these columns.
Then we have to remove where the IDs.
No. The problem is not where. I wanted this table, this other whatevers to appear. Or the ID.
You have to specify the columns.
Yeah. Customer ID. Product ID. Because you want it only for that one customer or that date. So we want it to display for us order ID, customer ID, product ID, order date. Then we are rounding this to 1 decimal places and let us rename the table, the column also as what? Let us rename the column as still the total price. From the table called orders, where the order ID is this. We want it only to display for us 1. Is it clear? Or let us change all these ones and see what will happen. Let me edit. Maybe 5, 6, 3, 2, 1. Those ones are more. Can also come to this and put 1, 3, 5, 6, 7. You can come here. We put 7, 8 is this. Then for the last one, let us put 4, 5, 6, 3. And then we apply these changes. Then we apply. It's successful, we finish. Even if you go back, you come to this, it should be able to display for you those ones. Now here, I don't now need the where. Is it clear? I want to see whether all these records here, their total prices will be rounded to 2 decimal places. So when we run this simple SQL statement, you'll find that it will display for us all the details, but it has been rounded to 2 decimal places. Is it clear? Yes?
It's clear. It's clear.
Yes, doctor.
Yes? Yes?
I think if you use format instead of round, it brings what Moses was asking about, displaying it with the instead of round. Instead of round,
if we use
format, it will display it
like this.
Yes, with the separator.
Okay, it will bring the separators automatically. Let us run and see. Yes, you'll see that it has brought the commas that the Moses was asking. Was Dramiga right? Yeah, at least today we have also learned one thing from a member.
Yeah.
That is a good one. We keep learning when practicing. You find, I think Dramiga, you are now happy.
I'm very, very happy.
Because there are very many inbuilt functions. We cannot exhaust them right now. You just need to go, you master them as long as you keep practicing. You find that you get more of these ones online. Then any other part, what about if you want to round it to maybe 3 decimal places? You'll find that these ones will come to 3. Is it clear? Now, what about if you want to round to 0 decimal places? You'll find that it will reduce what? It will remove the decimal places, or it will add them. If it's more than what? 4. Is it from 4? From 5? It will round to the nearest whole number. So when we put it 0, you'll find that it will round these ones to the next one. Those ones where the decimal places start from 1 and 5. Is it clear, members?
Clear. It's clear.
Now you don't want to use the column names.
You want us to pick all the columns. Select all from orders.
Like you say, select all from
orders.
It has brought for us error there already.
When you write the table name,
yeah,
then you remove from behind it. I want you to eliminate from here.
From here.
You now select, you put the table name.
Here.
Select all. From there, you bring the from orders before format.
What are we going to put there then?
Now we just make it now. You know what I was
select. You don't want us to continue doing this, but there's this error already. Select all from orders. Then what?
Let you continue. Just what I did want is
repeating those ones.
Repeating the columns when at the last also we are writing from orders also. Since the columns are on the orders table.
But what we want is we are applying that function on. We are applying that functions on total price. How are we going to apply the round function on total since we have decided to select all? Have you seen that one? Yeah. Yeah. So what you're thinking, it may not be possible. It's better we just what? We select the columns that we want to display. Now, that is using the round. Now, if we move back to customers, we have a table called customers. Assuming that from this table, we want to combine the first name and the last name, and we rename the column as full name. How do we do that? It is just very simple. We are going to use the concat function. We are going to select, then we concat. Concat, what are we concating? We are going to concat the first name, comma, then you can also say last name. Then we close it as
full name.
Full name from customers. I want us to, first of all, see the output of this. Full name, you separate words with underscore, not dash. Select concat first name and last name as full name from customers. When you run this, it's going to combine ASIC Dennis as one word without any space. So when we run this, what do you see? Now, when you run this,
Spelling of concat.
The spelling of concat.
Concat, spelling.
A concat.
Concat.
Yeah. How did I even write it up there? Yeah, it's correct. Concat. When you run this, you'll find that it will put you your full name, but it's going to combine what? Asiku Dennis as one word, Habib Hassan as one word, Adebo Thomas, Aziku Samuel, Amazolavan as one word. But we know that in full name, we have first name and last name. That's why we use what? The quotes up there. You put what? Comma, you put what? Single quote, space, another single quote, then you put comma, just to create that space. So that when you run this, you'll find that it will now display for you Asiku Dennis with that particular space. The more space you create inside here, I think the more it will do. Let us assume that it's up to that level. How does it display? You see that the space will be wider. Is it clear? Is it clear, members?
Yes, doctor.
Yes, doctor.
Very clear.
That's concat. Now, there are many aggregate scalar functions that you'll meet. As long as you keep reading, you keep finding others. You'll find that there's also first, there's last, but those ones don't work with this MySQL. You'll find that it works with another version of your what database management system. So you just pick those ones that you think that you can work with MySQL. So that is what we can do with inbuilt functions. Now, the next thing we're going to do is we are going to go back to our slides. We're going to learn about the wild what? The wildcard. These are still inbuilt functions. We shall come to user-defined functions. That's where you will be the one to write the functions. Then we have MySQL wildcards. MySQL support wildcards to simulate any other character in the string. Assuming that you have a lot of what? You have a lot of records in your table, and you want only to display maybe the names of customers that begin with a particular character. That is when you can now use the wildcard to do that. Usually wild characters are used with the like operator, and like operator is used in a where clause to search for matching pattern in the string. So So the SQL like operator is used with the where clause to get a result set that matches the given string pattern. It has the following syntax. You can put select the columns that you want it to display from where? From the table name, where the column like, then you display. For example, if in our table we want to select, we want it to deselect for us the records from all the columns and all the rows, but we want it to filter maybe the customers whose first name begins with maybe letter A. Then you are going to write a simple syntax like this. Even you are going to write a simple syntax like select all from customers where their first name, then you put the keyword like. Now in single quotes, you put single quotes, then you indicate that first character that you want the first name to begin. Maybe you want it to begin with A. Then you, after A, then you put what? Percentage sign, and then you close that single quote and then full column. Then it will go to the table and only pick for you all the customers whose first name begins with letter A. So here are some of the examples showing the different line operators with the percentage simple and the space. So you'll find that the like operators here is you have where address is like in single quotes, we have C, comma, which means that it will find for you fields values that starts with the letter C and then add a character. Then where address like percentage and then C, it will display for you, find for you the field values that ends with letter C. Then where we have also where address like, you have the what percentage side and then percentage side and close, which means that you can find for you the values where the names or whatever where there is AND in the middle. Is it clear? It may not be in the beginning, it may not be in the at the end, but it should be within inside the word that you have put. Then we have addresses where address like maybe comma dash 2%. It defines for you the values that have 2 in the second position, which means that the second position have to be 2. Then we have where address like C, percentage and Z, which means that the word must start with C and it must end with what? Z. So that is where you can use there. You can use the C percentage, I mean the wild cards. Then let us go first of all and see the example where you are going to implement what? This wild card. Because when you are developing systems or even in what? For those, anyway, we don't have people who are doing data science here. Like if you want to retrieve the records now, which are stored in the table, you will use a lot of this to filter for you the data. Then let me stop this and then we go and share our work, what? MySQL workbench. Then this is our MySQL workbench. Now, the first thing I'm going to do here is, let me first of all select all from customers. That is it. Select all from customers. Now, assuming that we want to write a simple SQL statement where we want to only retrieve all the customers whose first name begins with the letter A. Is it clear? You can decide to say select all the columns and rows from the table called customers where what? Their first name like begins with what? You type the keyword like, then we want the first name to begin with letter A. So when we run this, we know that from our table here, Aziku, and Amazon are the people whose first name, customers whose first name begin with letter A. So when we run this, you'll find that it displays for us what? We have Asiku, Adebo, Aziku, and Amazon, I think. Yeah, I think those three are the ones. Yeah. Amazon, ASICO, Adebo. It's only Habib which is not there. That's why you'll find that our result here, when we run this SQL statement, it will eliminate Habib because Habib's first name begins with letter H. Now, assuming that we want also to write a simple SQL statement to display for us the records of all customers whose first name ends with the letter O. Is it clear? Ends with the letter O. We know here it is Adebo and Amazon. Then when we run this, you'll find that it will go there and only pick for us Adebo and Amazon. What about all those customers whose first name ends with a particular one? We find here that Abibo, ASICO, and ASICO ends with the letter U. Assuming that you want those ones whose first name ends with the letter U. When you run this, you'll find that it will display for you ASICO and ASICO. So that is where you can use the live. Then what about if we go, let us first of all go back to this main table. We want MySQL to retrieve for us the names of all the customers that have the letters AB between their first word. Is it clear? That's where you can come here and then you put $, AB, and then you end with $. You know that the person here who's first in his first name where there's AB is, it is only AB is Abib, I think. There's no any other person. It's only Abib. We can run this. When we run this, it has to display for us only one record. That is Abib, whose name has AB in the middle. But if we go back, you'll find that between ASICO and the ASICO, what about if we want to retrieve the names of all the customers who have what? IKU in their name. You'll find that ASICO has IKU and then ASICO has IKU. So when you write this, you'll find that it will display for you only these two people because there's ASICO. After AS, there's IKU. Then ASICO, after AZ, there's IKU. It will go to the system and only retrieve for you those ones. Now, the other thing is, that is what? Now, that is where we retrieve a particular one in the middle. What about if we want to retrieve the records of customers whose first name begins with a particular letter and ends with a particular letter? I get it. Assuming that we want to retrieve the names of all the customers whose first name begins with A and ends with O. Is it clear? We can decide to say A and then let it end with what? O. Which means that it will go and pick for us the records of all the customers whose first name begins with A and ends with O. Here you'll see that it is who? Adebo. And then who? Amazon. So we should be able to have those two. That's why we have Adebo and the Amazon. So is there any question up to that level, members?
Yes, right, it's clear.
Up to that level.
It's very clear.
Very clear. Now, let us look at joins. Let us look at joins. We have ever heard of joins. So we are going to look at joins. Then let me see who are those ones who are not there today. ASICO Dennis.
Yes, doctor.
Your own. Tarome,
Yeah, I'm on.
I'm around.
The person who is not there is Hamid. And then there's this guy called who? Laban. Laban is there. There's this guy called Jau something. I've forgotten the other name. I've shared with you people all the chapters per group. But now I expected from today, you should have met in your group. Even if you're not physical, there are now very many ways. You can call each other, be it in this particular paper or be it in IT project management. So all of you in that particular thing, what I've given, I'm going to have group marks. I'm going to have individual marks, which means that everyone must participate. I can just decide to pick anyone in the group randomly. I'll tell you to explain for us this. That is where you'll find your individual marks. So you have to work as a team. Is it clear? You have to work as a team. So let us look at, let me stop this. Then let us look at, I think it's joins. We are done with wildcard. Let us look at joins. Wildcards. Under wildcards, there is also what we call not like. Not like is just the opposite of like. You can also use it. So I'll not talk about it because I'll assume that you'll do that one. That you can also use what? You can also use wildcards with multiple values, like select all from customers where the last name, like it begins with, it has the beginning and the end. It begins with R and ends with T, or where the last name ends with E. So you can also combine those multiple values in your wildcard. Then we are now going to learn what? Joins. We use joins. Joins are used to fetch data from two or more tables, which is going to appear as a single set of data by using the values common to both tables, which means that for you to use joins, you must have tables that have relationships. For us here, we have 3 tables that have relationships. So you can only use it in tables which have relationships. A join clause is used to combine rows from 2 or more tables based on a related column between them. SQL joins are what makes normalization possible, as they allow queries to return results that stretch across multiple tables. There are 5 different types of joins that we are going to learn. We shall look at inner join, left join, right join, full outer join, and then we shall also now finalize with a cross join. Now, SQL inner join, join in which the result is based on mass data as per quality conditions specified in the query. So the inner join keyword selects all the rows from both tables as long as there is a match between the columns in both tables. Suppose you have table A and table B. When table A joins with table B using the inner join, it will display for you what is in the intersection. You have the result set which is in the intersection of the table. So the simplest syntax for inner join is you are going to select the columns that you want to select from the table 1, then you inner join it to table 2 on. That is where now the relationship comes in. Table 1 dot column name equals to table 2 dot column name. For example, the simplest example here I've given in this slide is we have 2 departments. We have 2 tables called department and employees. In departments have been registered and those are the records. And then we have employees. You'll find that the department ID here, which is a primary key, becomes a foreign key under the employees table. That's why we'll have the department ID. So there's that relationship that is already been created. Now, if you want, that is how you create the tables and how you insert the data. I don't want to talk about it. Now, if you want to write a simple inner join to join these 2 tables, then you are going to use the aliases like what you used the other time. Is it clear? We are saying select d.department name, which means that we want to select the name, this department name from the table called department, which is known as D. Then we inner join it to a table called employee E, where it is abbreviated E on the department dot. The table called department must have a department ID that is equals to the department ID, which is a foreign key in the employee table. So we can decide to say, do this one, the simplest example here with our what? Let us see the simple example. Let me do it practically with our table here. Let me run the SQL. We know that when we select all from orders, we'll realize that we have order ID, which is a primary key, but customer ID and the product IDs are foreign keys because they are primary keys in customer and product tables. So you can now decide to combine two or more tables based on this. Assuming that we want to write a simple SQL statement, let us start to display for us C dot, let us say customer, we want to see the customer ID. We want it to display for us the customer ID column, C dot first name, comma, C dot last name, comma. You realize that it is all a table customer that is linked to what? The product. Then we want to know, yes?
There's a spelling error in the word customer.
Yeah, thank you. You can write customer. Then we want also it to display for us the order date. We can say to put O dot order date, comma, O dot what? Total price. From the table called customers, which is known by an alias called C. If you don't want to use as C, you can just put as C directly. Is it clear? Now we do what? This is what? Inner join, right? Then we inner join it. You type the keyword inner join. We want to inner join it to the table called what? Orders, which is known by an alias called O. On what? We are now going to join it on. You specify now the columns that link it. So what we want is C dot customer ID. The customer ID, which is in the customer table, should be the same customer ID that you put in the order table. You have customer ID, full stop. So what we are trying to hear is we are trying to join two tables, that is the customers and orders. We want the SQL statement to display for us the customer ID, the first name and the last name. The table customer here is referred to by the keyword C, and then order date and total price, which are known by an alias called O, from the table called customers, which is known by C. Then we inner join it to another table called orders, which is abbreviated by an alias called O. On what? There must be those matching what? There must be a matching column. We are saying now that the customer ID, which is in the customer table, should be the same customer ID you're going to put in the order table. Excuse me. When we run this simple what? SQL statement, it should bring for us only those customers who are able to make orders from the order table. So let us run this. You'll find that here, one, customer with C004 made an order. That is Samuel made an order on a particular date. So let us go and let us add another thing. We want to know the order ID so that we don't get confused. Can say DDoS order ID, comma. We want to know the order IDs for each of these ones. You'll find that customer C004, that is Aziku Samuel, make order on that date, and the total price was this. The same customer Aziku Samuel also made order D002, which is he made on that particular date. The total price was that. Then customer C001, that is Asiku Dennis, made order D003 and D004 on these dates, and these are the amounts. Then customer C002 made one order, that is D004 on this date, which means it is able to go to the table and only pick customers who have made orders. That's why you find that it is not displaying for you the list of other customers who have not made orders. Is it clear, members? Is it clear?
Yes, doctor.
Who has a problem before we proceed?
Yes, doctor.
Now, let us try. That is now using just customer and order. What about if you want to know the product? Which products did these people order? Is it clear? Now, let us go to our product. What are the columns we have here? We have, let us see the columns. You have product ID and product name. And what if we want also this table to still display for us the product ID and product name? How are we going to still do it using the inner join? It is very simple. Let me try this. I think it will work. We shall have, let it come after what? Order ID. We want to see the product ID. We can decide to mention it. We call it P dot product ID, comma, P dot product name, comma, then from customer, what? Let me start from here. From customer C, we inner join these orders on this by using this. Then we can also go ahead and we write another inner join. We want to inner join what? We want this time now to inner join the product. We are saying that P dot the product ID, which is in the product table, should be the same product ID that you have put in the order table. O dot the product ID. So what we're trying to say here is, why is it bringing that error? We're saying that P dot product should equals to, that's supposed to be, is it O? Yeah, I think, why is it displaying that? Is this O? What is this letter? It's supposed to be O. It's supposed to be O. O dot is the customer ID in the customer table should be the same customer ID you put in the order table. Then we also inner join the product ID, that is the product table should be the same order ID that we put in the order. O dot product ID. There's an error.
Is it not P?
Which one? There's P here. The product ID, which is in the product table, should be the same product ID that we have included in the order table.
The table.
Yeah. There's a syntax problem. Let me see. Let us just keep it aside. We shall handle it.
Okay.
We shall have to fix this problem. Why is it bringing this? Is not valid at this position for this server version expecting the N identifier. Okay. We shall do that one next time. At least let it work. If it doesn't work now, next time when we're doing it, it has to work. So that is with the inner join. I think you people are able to inner join two tables. Now let us go back and we see that is left, that is inner join. Now the next one is we are going to see what? Let us see, that is inner join. Now
Left
let us
and right.
left outer join and right outer join. The outer join is based on both matched and unmatched data. Outer joins are further subdivided into left outer join and right outer join. The left outer joins returns a result table with the matched data of two tables, then the remaining values of the left table and null for the right tables. So when we join table A and B with B, all the rows in table A, the left table, are included in the result set, whether there is a matching row in the table B or not. Which means that in, what do you call that one in sets? Those are the values of set A, right? The complements of what? Set what? Set B. Yeah,
Yes.
yeah, they are called the complements. It will only display for you all the list of complements of set B. The result is null in the right side, which means that it will display for you all whether it is matching or it's not matching. It will display for you. That is the left outer join. For example, the syntax is select column names from table A, left join table 2 on table 1 dot column this, then table 2 dot column this. We can see that example later. Then we have right outer join. The right outer join is the opposite of left outer join. Instead, it will now display for you the complement of set A. So the right outer join is the exact opposite of left join. It returns all the rows from the right table along with the rows from the left table for which the join condition is made. Right join is a type of outer join. That's why it is also referred to as right outer join. As we said it, the syntax is just like the other one. Instead of putting left join, this time you are going to put right join on table 1 dot this and this table this. The simplest example we have also there. Then we have full outer join. Full outer join is now the full outer join. We talked about left outer join, left join, right join, and then full outer join. That is now full join. So the full outer join returns a result table with the mass data of 2 tables, then the remaining rows of both left and right table. What do you call that one? Universal, eh? Yeah, universal of those 2 tables. It will be able to display for you. Now, how do you write the full outer join? The full outer join keyword returns all the rows from the left table and then from the right table. From left table 1, that is table 1, from the right table 2, which means that you are going to, first of all, to use full outer join, you are going to perform left outer join, then you are going to perform right outer join, then you are going to join the left outer join and right outer join using the keyword called what? The keyword called the union. It will be able to combine for you these 2 tables. So that is where you're going to use the full outer join. You'll find that the older versions of MySQL used to support what we call the full joins, but the new ones now support only the keyword union, because the union is the what? The total of the 2 sets. It's not like that. It will be able to display for you that. Now, you can see the simple example here. Left outer join is here, then the right outer join is here. The left and the right outer joins are joined together by the union keyword. And then it will be able to display for you what you want. Then let us first of all look at those examples before we move to, let us now finish with the cross join. A cross join is a join operation that produces the Cartesian product of the 2 or more tables. Can someone explain for us the Cartesian product? What does it mean? The mathematicians we have. Yes? Do we have mathematicians here? Yes, you can play. Unmute yourself while I mute myself. Okay, you can talk.
Okay, my understanding of the Cartesian join.
Hey.
It means that if you're going to do a Cartesian join between 2 different sets, because the idea is from the sets, it picks like all elements in set A, it multiplies it with elements in set B. The first in set A with an element in set B, then it picks another one as it finishes those ones, and then the second element also does that. That's the Cartesian join.
Is it clear, members? Do we still have people online?
We are online, but it is not clear, Doctor.
It is not clear.
48,
Yes,
20 minutes.
Who else can explain for us the Cartesian? Do we have mathematicians here? Yes? Or you want Habib to explain again? Laban.
Yes, please let him repeat for me.
Okay,
Let
Habib
him
can
explain.
come and help them. Come and sit here and help them. They know him. Okay.
Hello.
See you tomorrow.
Members, are you seeing my screen I'm sharing?
It
Yeah, we
is.
can see. We can see.
Yeah,
Now,
yeah, I've seen it.
Yeah, we are seeing.
So like if we're having set A, the elements 1, set 2, 3, 4. Like this is one set. And then we have another set B. With the elements, let's say this A, E, O. Is it O I first?
IE.
We have A-I-E-O-U.
Yeah, that one. Where is my? I pick the rabbit and refuse to go. Just use text instead of this one. Set A. With this I can say A, B, D, and we end it there. And then we're having set B. Let me move it in uppercase with elements E, F, G, and H. Oh, that's okay.
Yeah.
The other name, Cartesian product, sometimes we call it a cross product. That's why they mean doing this one there. Okay. So like if you want to get now A, we're crossing it with B. So there we'll get A. Let me create another. A times E. Are you getting that?
Yes, please.
All the elements A with all the elements in set B. The
A
first
times
applies
A times F, A times G, A times H.
We've gotten the concept that is the Cartesian product.
Then you go to B.
Then we go to B times E, B times F, B times G, B times H.
That's the Cartesian product.
Okay. It's okay with me now.
I think I'm stopping to share. People have gotten the concept.
Okay, thank you.
Okay.
Yes, Torome.
Torome can add on if I've mixed up.
I believe you are right. You see, when we are talking about a Cartesian product, so like when you multiply set A by set B, you are going to get a set of products from each of these sets, just like the way has been explaining. When multiply A by E, A by the next figure, and then after multiplying all of them, you come to the next one. That is a Cartesian product. You will obtain a set of all possible values from the combination of the two sets.
That one is not from a math teacher.
I think you people have got the concept.
Yes,
For some
doctor.
of us who ran away from mathematics, we had to hire machineries to help us. So I think it's very clear. Now the syntax for cross join is just simple. You write the select statement, select all from maybe customers, cross join tables. So it will do for you what? It will do for you the Cartesian product. So let us go. Let us now go and see how we can implement this one. The left join, the right join, the full outer join, then the what? The cross join. So basically we are going to stop here today. After practicals, I'm going to show you, demonstrate the example practically, and then after that, next week we shall start from views. Maybe we shall look at views. What else do we want to see? Maybe in user-defined functions, we shall also see it. Then from there, maybe triggers, procedures, we need to just get the understanding. Because some of you will implement the knowledge in there, whatever you want to do. So let me stop sharing this. Then let me share the what? Let me share the MySQL. So let us first of all select all from what? From customers. We have customer ID, first name, last name. That is a noun. Then let us select from orders. At least orders we know. Now let us start by left join. The syntax is just similar to the inner join that we wrote. Instead of the keyword inner join, we now put what? Left join. So we are going to select what? The columns that we want it to appear. We want, first of all, what? We want C dot customer ID, comma, C dot the first name of the customer, comma, well, C dot the last name of the customer, comma, then we want O that order ID, then we want O dot the product that O dot what? Order date. Order date. Then we want also O dot total price. Total price from where? We want from customers. C.
Spelling, please. Spelling of from.
Yes. Yes.
Spelling of
From.
From customers C. Then you type the keyword what? left join to what? We are going to join it to orders, which is known by any alias called O, on what? We want C, which is C.customer ID, which is there, should be equals to O.customer ID. So that when we run this, we'll find that it will only display for us a list of all what is in the set A, including the intersection, even if it is not there. Even if that customer did not make any transaction, it will indicate that, or if that customer did not make any order, it will indicate the fields as null, null, null. That's why you'll find that Adebo Thomas, together with who? Amazon Laban, they did not make any orders. Their fields are being labeled what? Null. Then let me copy this thing and paste it somewhere. That is left outer join. Now let us look at right outer join. Instead of left, we just combine these two. We change this to right outer join. So let us see the difference. When we run this, you'll find that it will display for us what? The table B, those ones which have matches. We know that in table D we had orders, which means that all those orders were made by particular customers. That's why you'll find that all the records of table orders will be displayed. Is it clear? Because it is customers that is linked to orders. So it will only display all the records of table B. Then the next thing is, if we want now to full inner join these two things, we are going to use the keyword what? That is the union. So if you want the full join, we are going to have this table. Let me even make it like this. We left join it, then we right join it, then we are going to combine left and right using the keyword union. So when we combine this as one statement and we run it, it will display for us this. Have you seen? It has displayed for us the records of Adebo and also the records of Amazu who did not make any order, which means that it combines left join and then the right join. Now, what about if we want to write? We want to write a simple SQL statement to cross-join these two tables. That is why we're going to use the Cartesian product. We just decide to put that select all from what? Customers. We want to select all the columns and rows in customers. Then we cross-join them to cross-join it to the table called orders. That is all. So that when we run this single statement, you'll find that it's going to display for us a lot of repeated things down there. Because like what Habib and the Roman said, it's going to multiply each several times. That's why you see that there are very many records, 63 items which have been included there. So is it clear up to this level?
Yes, doctor.
Yes, doctor. Is it clear?
You can also now select the columns.
Yes.
Some particular columns from the given table. The other table.
Yeah. You can decide to say that if you don't want all columns to be displayed, you'll see that it has repeated, I don't know how many columns here. It repeats these columns. When you look at this, you'll find that this first name, last name, sex, and so on is repeated. Then this other things is also being repeated there. It is really a long one. We can decide to say that we want it only to display for us. Let us say custom ID. First name and last name.
Last name.
Mm-hmm.
This is from customers.
Mm-hmm.
customers.
Just simple like that.
Then cross
Join to orders, which means that all the columns of orders will be added to these ones of the customer. We can only decide to say that we want that. You'll find that it is going to display for us what? First name and last name, but the record is repeated up to 63 times. Is it clear, members?
Yes, doctor.
Yes.
I'm seeing that these days the number of attendance is reducing.
It's constant.
Yeah, we are 14.
Not constant. I'm not seeing the Akumas here. I'm not seeing who else.
The highest can be around 16.
16, yeah. Some people are not attending. Juruka Hamid is not around.
There is Joel.
Akuma is in what?
She was around.
Akuma has just left.
We had Akuma and Wamusi, I think, who
also left.
Who have gone somewhere.
Is Joel who is not here?
Yeah, that Jiwen guy is also not here, which means that we are around 17 to 18 who are doing computer science.
Yes.
Yeah, so,
around there.
21.
And who?
Oh, according to my list, we're like 21.
Yeah, 21. Now, where are the rest? Now, if I decide to give you people a project and I want you to do some things, how will they participate?
We don't know.
Please try to advise your colleagues. Tell them to always be attending these classes. Okay. Because for Muni has a policy. Before you sit for an exam, I think you're supposed to have 75%. Always I'm taking attendance. I know those people who are always missing. At the end of the day, I'll give it to head of department and say, these are the ones who have been attending frequently and these ones have been missing. So they will now go and iron it out or sort it out with the head of department. So with that, we have come to the end of this particular lecture of today. Then see you guys next week. Next week, basically, we shall look at views. If possible, we shall look at functions, that user-defined functions, and then procedures maybe. We just see some simple examples. Then for more ones, you can now go and read about them. Is it clear?
Yes, doctor.
Yes, doctor.
Okay, good night. We stop here.
Okay, doctor.
Likewise.
Okay, doctor, bye.
Who is that one, Akuma? Is that part of my class?
Akuma is not on.
Who is the other lady?
We don't know.
Morris, is that not yours?
Sorry, doctor.
Okay, bye.
Okay.